All right, so in this video, we're going to continue with the elimination method to find a common solution between a system of equations. So here we have two equations, and we're trying to figure out what x and what y would make both equations identities at the same time. So what we're trying to do with the elimination method is add the two systems, the two equations together in the system so that one of the variables drops out. We don't care which one, we don't care which variable drops out, but we just want one of them to drop out so we can figure out what x or what y is. And then once we figure out what x or y is, then we can plug that value back into one of the equations and then solve for the other variable. So in the last video, we were adding the two, and one of the variables would drop out because let's say this would be a positive 4 and this would be a negative 4. This coefficient would be negative 4, and you add them together and it drops out to 0, 0y, because plus 4, positive 4 plus a negative 4 added together creates 0. But here, do you see when you add them together, it creates 9y. Here, do you see when you add these together, it becomes 8x. So if you add these two equations together, nothing's going to drop out. This is why you need to multiply through by something so that you get what we call additive inverses of one of the coefficients. So these are coefficients. A coefficient is a number that is right in front of a variable. So here 2 is the coefficient to x, 4 is the coefficient to y, 6 is the coefficient to x down here, and 5 is the coefficient to y. Okay, so we need these coefficients to ultimately be additive inverses, which means when you add them together, they become 0. So the additive inverse of 2 is negative 2. So if this coefficient, instead of being 6, was negative 2, then that would be great, because then you would add these two equations together and the positive 2 and the negative 2 would cancel out to 0. Or if this was negative 6, if this 2 up here was a negative 6, that would be great, because then you could add them together and the negative 6 and 6 becomes 0. Or for instance over here, this 4, if this 4 was not a 4 but instead a negative 5, that would be great, because then you would add it through and this negative 5, if it were a negative 5 plus 5 would be 0. So what we can do is we can multiply through and actually change one of the coefficients to be different, okay? And so it depends which variable we want to drop out. It doesn't matter which variable we drop out first, because we're going to be solving for both of the variables in the end. So let's look through here and see which coefficient could we change into the additive inverse, the sort of the exact opposite, so of some other coefficient here. So let's say, for instance, let's look at this 6. Is there any way that we could turn this 2 into a negative 6? That would be great if this 2 were negative 6. Well, we would need to multiply 2 by negative 3. If we multiply this 2 by a negative 3 times 2 is negative 6. That's it. And so negative 6 plus 6 is 0. So negative 6 and 6 are additive inverses. Okay? Additive inverses are numbers that when you add them together become 0. So for instance, negative 4 and positive 4, these are additive inverses. They create 0. Negative 100 plus 100, these are additive inverses, because negative 100 and 100 is 0. Negative 12 plus 12. Negative 12 and 12 are additive inverses. They become 0. Okay, so in this case, we could say that the additive inverse of 6 is negative 6. So to make this 2 into a negative 6, we need to multiply it by a negative 3. Now, here's the thing. If you multiply one thing in an equation, you need to multiply every other term in that same equation by whatever that factor is. You don't need to worry about the other equation. You just need to worry about this equation. If you're multiplying this equation by negative 3, you need to multiply every single thing in this equation by negative 3. Okay, so we need to distribute this over everything. So negative 3 times 2 is negative 6. Negative 3 times 4 is negative 12. and negative 3 times 8 is negative 24. So I needed to multiply every single thing in that equation by negative 3. So this entire equation up here becomes this equation down here. Negative 6, negative 12, sorry, negative 12. Negative 3 times 4 is negative 12. And negative 3 times 8 is negative 24. Okay, so now we have these two equations, which now we can add together. So let's add these two equations together now. All right, and we've got, okay, just making it there. All right, so positive 6 and negative 6 turns out to be 0. Great, so these drop out. 5 plus negative 12 is negative 7, so negative 7y. And positive 3 plus negative 24 is negative 21. Now I divide both sides by negative 7, and y equals, so negative over negative makes a positive, and then 21 over 7 is a 3. So y is 3. So if I'm looking for my xy coordinate that both of those equations would cross at, we know that the y value is going to be 3. All right, now we just need to figure out what the x value is. And again, we could put, substitute out y and put in 3 into any of these equations. All right, so let's let's just use this equation. So 6x plus 5 times y. We now know that y is 3, so let's plug in 3. Okay, and so that's 6x plus 15 equals 3. Subtract 15 from both sides. So 6x equals 3 minus 15 is negative 12. Divide both sides by 6, and you have x equals negative 2. And so that negative 2 is our x value of the point. So the point negative 2 comma 3 is the point where these two equations would intersect. Okay, so that's the solution. This point is the solution, the common solution to both equations. Meaning, this solution makes both equations identities when you plug in those x and y values. Let's try another one. Let's say that we have 5x plus 3y equals 17. And then our other equation is 6x plus 8y equals 38. Okay, now this is the trickiest one we've done up to this point, because do you see that none of the coefficients are additive inverses? So if I added these two equations together, 5 and 6 is 11x. X didn't drop out at all. If I added 3 and 8, that becomes also 11y. That didn't drop out. And unfortunately, I can't multiply just one of the equations through by a number, because neither of these, there's nothing that I can multiply 5 by to create a negative 6. And there's nothing I can multiply a 3 by to make a negative 8. So what I'm going to have to do is I'm going to have to multiply both equations by something. And so let's say that I want x to drop out. Again, there's a million ways to do this. You could choose x to drop out, you could choose y to drop out, it doesn't matter. In the end, we're finding out both what x and y are. Let's say we want to get x to drop out. Okay, so what is a common multiple of 5 and 6? 30. 30 is a common multiple. So if one was negative 30 and one was positive 30, that would be great, because then you would add them and they would become 0. So let's multiply, and again, there's a million ways to do this. This is just one way. Let's multiply the top by negative 6 and the bottom by positive 5. Okay, so now do you see that this negative 6 times 5 becomes negative 30, and this 5 times 6 becomes a positive 30? Now, if I wanted to, I could have multiplied the top by positive 6, and that becomes 30, and the bottom by negative 5, that becomes negative 30. That's another way to do it. That's great. I just have to pick one way. Remember, if I multiply this 5 times negative 6, I need to multiply every single thing in that top equation by negative 6. Likewise, I need to multiply everything in this bottom equation by a positive 5. So let's do that. So this right here, this top equation becomes negative 30x, negative 6 times 3 is negative 18y, and negative 6 times 17, oh boy, I'm going to have to do that out. I can't do it in my head. All right, so 6 times 17, 42, and then 6, 10, so that's a negative 102. All right, it's a big number, but it'll work. Negative 102. So negative 6 times positive 17, whoops, gives us a negative 102. So 42, 6, yep, that should be right. Okay, now let's do this bottom equation. 5, a positive 5 times 6 is a positive 30, x. That's why we're doing all this. So this becomes a negative 30 and this becomes a positive 30. These are additive inverses, so the x will drop out. That's why we're doing this whole thing. Okay, 5 times 8 is 40, y. Now 5 times 38. Okay, I don't know what that is. 5 times 38 is, let's see, 40, that's 15, and 19. It's big numbers, but it'll work out in the end. All right, so that's 190. So let me just double check. 40, 15, yeah, okay. So now do you see that I can add these two equations together and the x's will drop out, thankfully. Negative 18 plus 40 is going to be, let's see, is that going to be 22? 22y? Let me just make sure in my head here. So 40 minus 18, that's a 3, and then a 10, 2, yep, 22. All right. So do you see that the arithmetic becomes more difficult with this? And that's why these problems take more time. You just have to do the arithmetic, but it's okay. It'll work out in the end. And then negative 102 plus 190 would be a positive 88. So negative 102 plus 190 is a positive 88. Okay, when you add these together. Great. Okay, so now we have 22y equals 88. Now we need to isolate y by dividing both sides by 22. And 88 divided by 22 is 4. 4 times 22 is 88. So y equals 4. Oh, it was a lot, but we got to it. So y equals 4. We know that these two equations, if they were graphed out, would cross at a point, and that point would have a y value of 4. So I'll just write our solution over here, x comma y in x comma y form. We know that the y of this solution would be 4. Okay? Now it's straightforward in terms of that we plug 4 in for y. And it doesn't matter which equation. I'll do the top equation here. So I can go back to the original equation, which looked much simpler than what we turned it into. So 5x plus 3y equals 17. That's an original equation that we had. And so we put 4 in for y. Okay, so 5x plus 3 times y, which we now know is 4. Okay, so that's 5x plus 3 times 4 is 12. And that's 17. Subtract 12 from both sides. So that's 5x equals 17 minus 12 is 5. And I divide both sides by 5. And I have x equals 1. Okay, so I know that now the solution is 1 comma 4, meaning that the two equations, when graphed together, would have crossed through the point 1 comma 4. It's a lot, but if you go step by step and are careful with your arithmetic, it'll work out.